Okay, now that we know a little bit about what complex numbers are, we're going to have to learn to work with them a little bit better. So we're stepping out of quadratics for just a lesson and learning how to do basic arithmetic. So add, subtract, multiply, divide complex numbers. So remember that every complex number is a number that can be written as, like this one, 3 plus 2i. It's got a real component and it's got an imaginary component. Right? Okay, so we need to learn how to add, subtract, multiply, divide. And this is actually follows very closely with rules you already know. So if I'm going to add and subtract complex numbers, you're going to add and subtract, let's see, kind of like components. You know how we always say like terms? We're going to say we're going to add and subtract like components. So the real components need to be added or subtract, and the imaginary components need to be added and subtract. So here in these two complex numbers, my real components are 3 and 1. So I have to add my real components, and then separately I'm going to add my imaginary components, the 2i, and I'm adding to that a negative 1i. So I'm getting, as my answer, 4 is my new real component. That was my 3 combined with my 1. And my positive 2i plus negative 1i is going to give me a positive 1i. And you can write that 1, or you can just choose. Most of the time we don't write that 1, we just say I. Okay, so we just combined our like terms. So in this next one, same thing. I'm sorry, combined our like components. So here are our like components. We'll need to do 6 minus 1. And then separately, our like components are our imaginary. We've got a negative 2i, and from that we're subtracting another negative 2i. So 6 minus 1, that'll give me a new real component of 5, and a negative 2i minus another, so minus negative is really plus, so negative 2i and a positive 2i gives me 0i as my component. And that's a number that you know normally. This is just the number 5. Right? It has no imaginary component. So when I combine those two complex numbers, I get just a regular number, a real number. But you can write it as 5 plus 0i or just 5. I'll take it either way. Here, it looks like a little weird. It doesn't look like we're adding complex numbers, but remember, you can write 7 as the real is 7, the imaginary is 0i, and from that we're going to subtract 4 plus 2i, right? So the real components is 7 minus 4. 7 minus 4 is going to be 3. The imaginary component is 0i minus a positive 2i, so we know that's going to be minus 2i. Okay? So adding and subtracting complex numbers is just combine like components. Forgot to put the word combine up there. There we go. Combine like components. So, again, sticking to rules you already know, when we add and subtract, we combine like terms. That's a phrase you knew before. But when we multiply and divide, we do it to everything. Same thing here. So when I'm going to multiply these two things, I'm going to multiply to both. So 2i times a negative 1, that's going to be a negative 2i. And then 2i times 3i, 2 times 3 is 6. I times I is I squared, right? Now, I is not a variable. It's just, it represents a number. And complex numbers don't have I squareds in them. Complex numbers are made up of a real component and an imaginary component. So a number and a number with I, not I squared. So what is I squared? So pause for a minute and go back. Remember, I is root negative 1, right? So this is just it's an equation, it has an equals, right? So I can do whatever I want to both sides. Suppose I choose to square both sides. So if I square I, that's I squared, right? If I square negative 1, the square and the root cancel each other. So all I'm left with is negative 1. So I squared is really negative 1. So I need to fix this. 2i plus 6 times negative 1. So really I've got negative 2i. Positive 6 times a negative 1 is a negative 6. And it's just that normally, I'm going to move this guy down a little bit. Normally, we write the real component first, then the imaginary component. Right? So this is my final answer when I multiply those two things together. Okay, let's look at some more. So some more multiplying. Here's two complex numbers being multiplied together. And we do it just like we normally do multiplying. The 6 needs to be multiplied to everything, and then separately the 3i to everything. So 6 times 4 is 24. 6 times negative 3i is negative 18i. Positive 3i times 4 is positive 12i. And positive 3i times negative 3i is negative 9i squared. So we know we're going to have to fix that I squared. And we've got like components right there in the middle. Okay, so let's work with this. Get this guy down. All right, so we've got 24 will stay. Negative 18i and a positive 12i combines to be a negative 6i. And then we know from above that I squared is the same as negative 1. So really we've got 24 minus 6i plus 9. And we've got like components there. Our real components are alike, so we need to combine them. 24 and 9 makes 33, so 33 minus 6i. So when I multiply those two complex numbers above, I get 33 minus 6i as my new complex number. Okay. I put this one on here on purpose. These are very special complex numbers. When it's the exact same number, but one says plus and one says minus, these are called complex conjugates. And I just want you to look and see what happens when we multiply complex conjugates. Okay, so the 3 times both things would be 9 plus 15i. Then the negative 5i times both things would be negative 15i. And, nope, not positive, negative 25i squared, right? All right, we've got like components that are actually positive 15 and negative 15 are going to cancel each other. And then, let's see, I squared we know is negative 1, so we've got 9 minus 25, parentheses, negative 1. That's really 9 plus 25, which is 34, which is just a regular number. Remember, we could think of that as 34 plus 0i if we want to really write it as a true complex number. But what happens when you multiply complex numbers together is your result is a real component only. Okay, and this is going to be very important for our next slide here. So that when you have two things that are the exact same, but one's plus, one's minus, when you multiply those two complex numbers, the imaginary component cancels out, and you end up with just a real component. That's important. All right, so that was adding and subtracting and multiplying, which means we still have to do some dividing. And actually, dividing with a complex number is actually super, super simple. You know how to divide. We divide each part, right? So this is the same as 10/3 minus 6 divided by 3 is 2i. So the real component is 10/3, the imaginary component is 2i. That's not so bad, dividing by just a real number with no imaginary component. However, when we start dividing a complex number by another complex number, life gets a little bit difficult, but it's still doable. The question is, can we fix it so that we are dividing by a real number only? Is there a way to fix this problem? Now, one thing I need you to know is this is not an equation. There's no equals going on here, right? This is not an equation, so we can't do whatever we want to both sides, but let me ask you something. If I multiplied this expression by 1, would I change it? When you multiply by 1, does it change anything? No. What I want to do is change the way 1 looks. Let me ask you something. Instead of 1, if I wrote 3 minus 4i and 3 minus 4i over itself, isn't anything over itself the same as 1? So I'm still multiplying by 1, I just changed the way the 1 looked. Now why did I pick 3 minus 4i over 3 minus 4i? Why am I doing this? And by the way, what I'm doing is I'm multiplying the numerator and denominator by the complex, we just had this word on the last slide, conjugate of the denominator, conjugate. I chose 3 minus 4i because it was 3 plus 4i. Why did I pick that? Well, let's multiply this out. I'm going to come down here and do this. So I have to remember to multiply fractions in case you've forgotten, across the top, across the bottom. So I need to know what is 10 minus 6i. I'll have to do that times 3 minus 4i. And then separately, I need to do the bottom, 3 plus 4i. Here are our conjugates, times 3 minus 4i. I'm actually going to do that part first. Let's do our conjugates real quick. 3 times 3 would be 9. 3 times negative 4i is negative 12i. Positive 4 times both things is a positive 12i and a negative 16i squared. These guys cancel out. We know that I squared is the same as negative 1. So this is 9 plus 16, which is 25. So what I'm getting on the bottom, when I multiply these complex conjugates together, what I'm getting on the bottom is really just 25. And then we're back to a problem that looks like our original, where we had just a real number on the bottom. We know how to divide that. Okay, so again, I'm multiplying by the complex conjugate over itself because that's multiplying by 1, so I'm not changing anything, just changing the way it looks. Still need to multiply out the top though. So 10 times 3 would be our 30. 10 times negative 4i is negative 40i. Then the negative 6 times both things, positive 24i squared. So here, let's see, we don't cancel out. So 30, negative 58i. I squared is the same as negative 1. I'm going to have to move my work down a little bit. Ran out of space. Hang on one sec. Scooch that guy down a little bit. All right, so we've got 30, I lost my I. 30 minus 58i plus 24 times negative 1. So really we know that's 30 minus 58i minus 24. And 30 minus 24, those are like real components. So 30 minus 24 is 6 minus 58i. Remember, this was the top part of our fraction. Top part of our fraction. 6 minus 58i. And then we would split that apart and divide it if it's divisible. Let's see. 6 over 25 is not reducible, so we have to leave it like that. Minus 58 over 25 is also not reducible. Whew, that's an ugly complex number. Fraction real component and a fraction imaginary component. But when we divide, so remember when we divide, here's our new complex number answer. Okay, and then I've got some more examples on here, but I'm going to keep this video short. So you'll be doing some of these examples in class. Just to get you started though, if you were going to do this one, you would multiply by the complex conjugate of the denominator so you could make it a real number on the bottom. And you got to multiply by something over itself, so you're really multiplying by 1. If I wanted to do this guy, if I wanted to do b, I'll just have to show it kind of tiny. I would multiply by 5 minus 9i over 5 minus 9i. So the complex conjugate of the denominator so that we can get a single real number on the bottom. Remember, that's our goal, is to get a real number. Then we can split it apart and divide.